All right, we're going to be looking at radical expressions in today's lesson. So what is a radical? So first, a radical is an expression with a root. Oops. Such as a square root. So that's the one you're probably most familiar with. Cube root, you've probably also seen before in algebra. Oops, root. You also might see like a fourth root, etc. You can have a fifth root. So really, a root is essentially undoing something with an exponent. Okay. So we'll look here the different parts of our radical expression. Here we have our index. Now, typically, we've been under the assumption that the index is 2, or if you don't really see a number there, we're going to assume that it's 2. So, for example, you've probably just seen, square root 25, or you've seen radical 25 is actually what that is. But if there's no 2 here, we just assume that it's a 2. So, what we are looking for is a square root. Okay. This part here, that's called the radical, and the number underneath it, radicand. Okay, so we're just going to list out the first 12 perfect squares. What I mean by that is what is 1 squared, 2 squared, 3 squared, 4 squared, and so forth. And I'm writing squared out as well. You don't have to do that. I just want to make sure you know where the numbers I'm getting came from. And these should be memorized somewhat just because you've probably had so much experience multiplying these numbers by each other. But if they're not, you can use your calculator. So 1 times 1 is 1. 2 squared, 2 times 2 is 4. 3 squared, 3 times 3 is 9. 36. Oh, sorry, 16. 25, then 36. 7 times 7, 49. 8 times 8, 64. 81. 100. So we can actually make, and that's why they're called perfect squares, we can make the shape a square out of these side lengths here. Okay. And then we can go backwards from this. So for example, square root of 1 is going to give me 1. Or square root of 4 is going to give me the answer 2. Square root of 9, that's going to give me the answer of 3. So square root of 36 is really what number multiplies by itself to make 36. So we can almost see it as 6 times 6. Okay, so the square root of 36, because this is index is 2, we need 2 of the same number to be a square root. Square root of 36 is 6. We've got square root of 121. That's going to be 11. Now, if something's not on our list here, we just need to go ahead and put that into a calculator. So you might have a calculator in front of you. I'm going to find the square root button, 441, and that's going to be 21. I'll let you find the next square root here. And then with this one, you're going to have operations with perfect squares. So anytime you have a number in front of a radical, and then you have a part here, we want to simplify that. So really that's showing the multiplication of 2. Square root of 100, right, is 10. So we're going to do 2 times 10 for that, and that's going to be 20. And then I'll let you finish number 6 independently also. Okay. Now, what we want to look at is what do we do when something is not a perfect square? So, for example, square root 32, let's put that into the next step of our next line of our calculator. Let's put in square root 32. Now, it's giving us a decimal here. And unfortunately, this calculator does not put our answers in simplest radical form. If you have the answers or the calculator checked out from the library, if you have a certain type of calculator, it might give you the simplest radical form for that. So square root 32, we don't want a decimal for it. We want an exact answer in simplest format. And in order to be in simplest format, we have to find the largest perfect square that this number here is divisible by. So what perfect square goes into that number? 32. Okay, so we start kind of looking at our list here, list of perfect squares, and we say, okay, well, 25 doesn't go into 32. 16 goes into 32. Or you can kind of start down below here and say, okay, well, I know 1 goes into everything. 4 goes into 32, but is there a number that's bigger that goes into 32? 9 does not, nope, but 16 does. So you can kind of go on the list either way and start checking numbers that go into that. I know that 32 has factors 16 and 2, and 16 is a perfect square. 2 is not. So we would say in simplest radical form, well, we do know the square root of 16, that is 4. So in simplest radical form, we would write this as 4 square root 2. And you can check on your calculator. Let's check to make sure that is equivalent here. If I type in 4 and then I put square root 2, you'll notice that they have the same decimal equivalent value. It's just that this is what we call simplest form. Okay, let's look at the next one. So 48. We can start kind of checking numbers that go into it. So I know 4 is going to go into that. I know that's 12 times. Then we want to say, okay, well, is there a bigger number? 9 doesn't go into it. Let's check 16. Let me do 48 divided by 16. Divided by 16, and it goes in 3 times. So 16 would be the biggest number that goes into 48, because I know 25 is not going to go into it. I know 36 is not going to go into it. So this would be simplified as square root 16 times square root 3. So then you should be able to simplify that in simplest radical form. Okay. Now for the next one, 180, well, I'm going to show you kind of a strategy that will work to break this down. If I don't know what the biggest perfect square is, there's a method to finding it, and it's called finding the prime factors. Okay, so I'm just going to find the numbers that multiply to make 180. Okay, so I'm going to write that in a string of numbers, kind of like what I did here. I found out that the numbers that multiplied to make 32 were 16 and 2. 16 times 2 multiplies to 32. Well, I was lucky that I already had the 16, but what if I didn't have the 16? So let's try this again. Let's try 32 with 2 other numbers. Let's just say 4 times 8. And then I'd say, okay, well, this prime factors out to 2. This is 2 and 4, and this is 2 and 2. So another way of writing square root 32 is all of the numbers multiply by each other. There's 1, 2, 3, 4, 5 2's. 2 times 2 times 2 times 2 times 2 is another way of saying 32. You can check on your calculator if I did 32 5 times. You'll see here 2 times 2. Showing multiplication with all of that. So 32. Another way of saying it through prime factors is 2 5 times. So what I'm looking for, remember, because it's a square root, I'm looking for pairs of numbers. So square root of 2 times 2 would be 2. Square root of 2 times 2 is also 2. And 2 times 2 is going to give me this value here of 4. Okay. And then if you wanted to break it down even further, you could say, okay, well, if I have 2 times 2 is 4, times 2 again is 8, times 2 again is 16. That's really where the 16 is coming from, which is what I'm finding is the biggest perfect square that goes into it. So let's back this up and kind of start with a different problem. Okay, so this is kind of a longer approach or method to figuring out the biggest perfect square that went into 32 if I didn't automatically know it just by looking at it. So let's look at this next number here. We've got 180. I don't know what the biggest perfect square is that goes into it, but I do know that, let's say, 18 times 10 multiplies to 180. 18 times 10. Now I have to do all the factors for this, so then I can do here 2 and 5. Okay, now those are done. Can't take any more factors of either of those, and I've got 9 and 2, and then I've got here 3 and 3. Okay, so now with my prime factors, I'm going to write this out. Another way to say 180 is I like to just kind of list out the numbers grouped together. So we've got a 2 times 2, 3 times 3, and then we've got the 5. So if I were to multiply 2 times 2 times 3 times 3 times 5, it's really the same thing as 180. And remember, because we're looking for square roots, this is the square root, I need groups of 2 numbers. Okay, so 2 times 2 is 4, 3 times 3 is 9, 4 times 9 is 36. So really another way to write this beginning piece here is this is 36. 36 is the biggest perfect square that goes into this. So this is really square root 36 times square root 5. And the square root of 36 is 6. And I can kind of just go from this step here all the way down to this step here. And that's because square root of 2 times 2, this piece here is just 2. Square root of 3 times 3 is just 3. And 2 times 3 is what gives me this value here as 6. Okay, so remember, square root means we need 2 of those numbers on the inside to make one of those numbers on the outside. Okay, let's try one more here. We have square root 175. That's going to, let's try 25 and 3. Oh, no, not 25 and 3. That's going to be 25 and 7, right? Because 4, yep, 25 and 7. Okay, and then this is going to be 5 and 5. Well, I didn't even need to bring down those factors there, because if I think about it, we have squared 5 times 5 times 7. Well, I know square root of 5 times 5 is just going to be 5, or I could have said square root of 25 times square root of 7. And then we've got 5 square root of 7 here. Okay, and on the second page, what we're looking at is multiplying radicals with each other. So we have 4 multiplied with square root of 2. It's kind of like saying, what is 4 times x? Well, it's just 4x, right? We have a number, we have a variable. We want to kind of think of it as like terms. So 4 times square root of 2 is 4 root 2. Okay, anything on the outside is going to multiply with numbers on the outside. Numbers on the inside are going to multiply with each other. So this 2 and 2 will multiply, but 9 has nothing to multiply with it. So 2 times 2 is 4. And then making sure we simplify our final answer. Well, square root of 4 is not simplified. I know there is a square root of 4, and the square root of 4 is 2. So this is really 9 times 2, which is going to simplify to 18 altogether. Okay, remember numbers outside. So 7's on the outside. 3 times 2 is that's going to be on the inside. 6. Now 6, there is no perfect square number that goes into it, so that is fully simplified. And then here we've got 12 that's going to stay on the outside. 6 times 2 is going to be a 12. And then we'd say, okay, well, is square root of 12 fully simplified? Well, I know 12 is 4 times 3, which is 2 times 2. So that's really 2 times 2 times 3. Well, square root of 2 times 2 is 2. So I'm going to say that this is 12 times 2 root 3. 2 root 3 is the simplest form of square root of 12. And then 12 times 2 is 24. So 24 square root of 3. Okay, then you can try multiplying with square roots of 3 here. And you'll see later on in this unit why we're multiplying by square root of 2 and square root of 3 a lot. And then our final step is dividing. So in order to be fully simplified, we don't want radicals in the denominator. Okay, so in order to, we call rationalize it, get the radical out of the denominator, we need to multiply both the numerator and the denominator by this radical in the denominator. So we're multiplying by root 2 over root 2, because really that's just multiplying this whole expression by 1, and we're not changing the value. That gives us 10 root 2 in the numerator, and it gives us 2 in the denominator, because if you think about it, root 2 times root 2 is square root of 4, and the square root of 4 is 2. So that's why we're multiplying by that. If these two numbers here can be simplified or divided, you would want to divide them. Well, 10 divided by 2 is 5, and this would be our final solution here. Okay, so we can multiply by root 2 over root 2. This would give us 12 square root of 2 over 2. And you can go ahead and divide this. What is 12 divided by 2? We'll try that here. Root 2 over root 2. Multiply those. 7 root 2 over 2. Now with this one, 7 divided by 2 is going to be 3.5, or it's going to be 3.5, or a fraction, or it's just going to stay 7.5. So this would be your final answer. You can't simplify that any further. So I would only simplify it if the numbers on the outside can simplify with each other. Okay, then you're going to try these last parts on your own. We'll multiply by root 3 over root 3. I'll let you simplify that out. 6 root 3 over root 3, or just over this regular 3. Divide these two numbers if you can. And then as you're finishing the rest of the problems, if they can't be divided by each other, you would just leave it as a fractional expression. This one you'll want to simplify.